Hello, statistics and pre-calculus. Welcome to your next video on 7.1. So today we're going to be using the rational zero theorem that we just proved to find some zeros of some polynomials. So this is actually your last video unless you want to check out the bonus content I'm going to post next. So in this video, we're going to be using the graph of the polynomial to help us find our zeros. In the next video, which is a bonus video, we're going to be doing it the total old school way, which is to basically guess and check until you get it right and go from there. So just so you know, this is a required video. The next video, if you want to see how you do it by hand, the long old school way, you're welcome to watch it. If not, you can stop your knowledge of 7.1 right here. That being said, let's look at our example. So we have this lovely graph here corresponding to our polynomial 2x cubed minus 7x squared plus 9. So what do I notice? I see that I have three x-intercepts, right? One here, and one here. Now, I know that this one is not a whole number, but this one looks like it is. This one looks like it's -1. So I'm going to go ahead and say that one of my x-intercepts, or one of my zeros as we call them in this unit, is -1. Now, if one of my zeros is in fact -1, one of my factors of this polynomial is x plus 1. Use a thinking exercise to go through this, right? So if my intercept is -1, I'm going to have to get that by setting x plus 1 equal to 0, moving 1 to the other side of the equation in which it becomes negative. So one of my factors is x plus 1 is what I'm going to say. Now, what's left over when I divide out x plus 1 from 2x cubed minus 7x squared plus 9? Great question. We're going to have to do some substitution division to figure that out. So first things first, going to write 2x cubed minus 7x squared plus 9 in our standard form, accounting for any zeros we need. So do we need zeros? If you said yes, you're correct. So note here, I do not have an x term, so I should have plus 0x plus 9. In which case, I'm going to take my coefficient a, which is -1, and I'm going to bring down my coefficients. I should have 4, right, of my polynomial. 2, -7, 0, and 9. One mistake you might make is forgetting to put that 0 there. That's crucial. So now I'm just going to do my substitution division. So we bring down this first one. We have a 2. We multiply -1 times 2. We should get -2. That goes here. And then we add these two terms together. So we have -7 plus -2 equals -9. Do it again. -1 times -9 is +9. 0 plus 9 is 9. -1 times -9 is -9. 9 plus -9 is 0. So x plus 1 is our factor out in front, and our remainder is what's left of 2x cubed minus 7x squared plus 0x plus 9 once we pull out our x plus 1. So in this case, what we have left is, 2x squared. So sorry that work went away, guys. Minus 9x plus 9. Let's do a quick fact check here. So we have x times 2x squared is 2x cubed. X times 9x is -9x squared. X times 9 plus 9x. And then we have 1 times 2x squared is positive 2x squared. 1 times -9x is -9x. And 1 times 9, is +9. So what do we see here? These guys cancel out. -9x squared plus 2x squared gives us -7x squared, so we're left over with 2x cubed minus 7x squared plus 9. Check. Is that where we started? 2x cubed minus 7x squared plus 9. Yes. So go ahead and erase this. And our factored form here is x plus 1 times 2x squared minus 9x plus 9. Now, if you're feeling brave, maybe you want to try to factor this to find our other two zeros, We could also at this point use quadratic formula to find our other two zeros. It's really up to you. What I'm going to do though is go back to my graph and notice that this guy here also looks like a nice whole number. In fact, I'm pretty sure that one is 3. So I'm just going to go ahead and say that my next zero equals 3. And I'm going to repeat my process all over again. I'm going to say that my next factor is x minus 3. And I'm going to divide 2x squared minus 9x plus 9 by x minus 3 to find what's left. So again, we take our a, which in this case is positive 3, and we take our coefficients of our polynomial. Now note that in this case, we no longer need zeros because we have an x squared, an x, and then an x to the 0 or just a 1. So I just pulled my coefficients down of 2, negative 9, and positive 9. Once again, pull down your 2 to get started. 3 times 2 is 6. Put that here. Negative 9 plus 6 is negative 3. 3 times negative 3 is negative 9. Put that here. We cancel out here. We're left with x minus 3 times 2x, minus 3. Once again, we might want to check to make sure that that does in fact equal 2x squared minus 9x plus 9. So we're going to say we get 2x squared minus 3x minus 6x plus 9. Let's see, looks like we got it correct. Remember that these will simplify down to minus 9x, so we'll have 2x squared minus 9x plus 9. So this is our correct last factor. So we now have x minus 3 and x plus 1 as 2 of our factors, from which we have already gotten 2 of our 3 zeros, right? Negative 1 and 3. And finally, this last factor is in a form that we can actually work with. So let's just set this equal to 0 and find our last 0. So we'll add 3 to this side. We have 2x equals 3. We'll divide by 2 on both sides and end up with x equals 3 halves. Let's just go back up and sanity check. Does this look like this could be at 3 halves? Well, this intercept does look like it is between 0 and 2 and closer to 2. 3 halves is 1.5. So I'm feeling pretty confident that we did this right. So using our graph, some common sense, and rational zero theorem, we've essentially come up with the fact that we have 3 zeros in this graph, and they are negative 1, positive 3 halves, and positive 3. All right, great job, guys. Check out the last video if you're interested. Otherwise, enjoy 7.2.